Okay, so we're doing 1.4, and it will be interesting as you work through this section that you compare it to section 1.2 about segments. This time we're going to talk about angles. A lot of the ideas are very similar. So let's go ahead and get going on it. Now on some of these problems you might need to use a protractor, just like you needed a ruler before. And I do have like a classroom set that we can share. So for those couple problems you can use them. But we're going to learn how to do how to measure angles a little bit. Okay, so our objective today, students will be able to classify angles according to their measure. And so one of the things we're going to learn is whether an angle is acute, a right angle, or a straight angle. There's one other type of angle in there that's not listed there, but that's an obtuse angle. Okay, so we're going to learn about angles. Some of the stuff you probably know already. Okay, so here are some definitions. An angle consists of two rays with the same endpoint. So here's a drawing. Huh? Oh, I'll give that to you here in a little bit. Don't worry about it. I'll pass it out. So an angle consists of two rays with the same endpoint. The endpoint that's common to both rays is called the vertex, as you can see right here. And so there's a little picture. Now one of the things we need to do is learn how to name these, just like we learned how to name segments. We learned how to name points and planes, and rays. An angle now is what we're going to try to learn how to name. And so we're going to learn how to do that here in just a few moments. Okay, so naming them now. Okay, so when we name angles, the thing to the thing to realize is that there's 3 points involved, right? There's this point, and this point. So if we want to refer to this angle up here, we'd have to use those 3 points. And the only other thing we need to do then is use the angle symbol. Angle symbol kind of looks like an L that's slanted. Everybody see that okay? And so then you use the 3 letters. Okay? So I could call this W, X, Y. And that would be referring to this angle on top, right here. Bam. Oh, there is one thing you should know though. The vertex is always the one that's in the middle. Okay? So you could actually name this angle on top using the same 3 letters but in the reverse order. Like you could say that this is angle Y, X, W. Either one of those is okay for this first angle right here. Make sense? Okay? So real quick, why don't you practice how would you name this angle here? There's 2 ways to do it. You should try it real quick. I'll give you about 10 seconds. You can try it on your own paper real quick. Make sure you use the angle symbol. Okay, I'm assuming you're done by now, but let's see here. I'll use a different color. Yeah, cool. Use black. I could call this angle Y, X, Z. Remember, the vertex is the one that has to be in the middle one. But these two could switch around. So you could also call this one angle Z, X, Y. And we use capital letters because these are points that are on the that are on the angle. This, they're on the rays and stuff like that. So it should make sense that we're using capitals. Any questions? Now that you think you have it figured out, why don't you name the bigger angle, the angle that goes from here to here? How do you name the big one there? Use the angle symbol, and then what?
X, no, Z.
Okay.
Z.
Z.
X.
X.
W.
W, that works. Z, X, W. What's the other way we could do it?
X.
W, X, Z. Okay, so you all get an idea how you name these. Pretty easy, right?
Yeah.
I might add that there's a few shortcuts sometimes. Sometimes we'll have like a number in here or something like that. Like I might put like a 1 there and a 2 here. Does that make sense? Mm-hmm. If you have a number that's kind of written in here by the vertex, we could call this angle that's on top here, we could say it's angle 1. Does that make sense? And so that would be referring to this angle from here to here also. That's kind of a shortcut way of doing it. And so this angle down here, we could say it's angle 2. This one right here on the bottom. So that's a little shortcut method. There's one other shortcut method that we might use, but we only do this as long as there's no confusion whatsoever. So let's say there's an angle that's sitting out there somewhere. There's another angle over here. And we have 3 points on there like this. Like we might have A, B, and C. Okay, so there's my ray here and ray here. Is this cool or what? I'm using 2 different colors. I know you guys are impressed. Okay, but anyhow, we have 3 points here. We might have D, E, and F. So one other way that we might name this angle, when there's no confusion, we might take another shortcut. We might just call this angle E. Make sense? If you're going to name it using only one letter, it has to be very clear what that angle is and where it's at. If there's any confusion, you have to use the 3 letters again. Like right here, you can't get by with angle X, can you? No. Because there's 3 angles there. There's one there, there's one there, and then there's the big angle. So when you say angle X, I have no clue which one you're talking about. But if there's an angle all by itself, then you can get by just using a single letter. So in this case, since this angle is all by itself, you could call that one angle B. And the letter we use is always the vertex on that one. Don't call it angle F, okay? Because there's no angle up there. Okay, so those are the kind of three ways that we'll name angles. Hopefully everyone gets that. Makes sense. So now we want to classify angles, and you've probably seen these all before. If an angle is less than 90 degrees, it's an acute angle. If it's exactly 90 degrees, it makes a right angle. Now this should remind you of a square. That's because in a square, if you were to draw a square, you have 4 right angles in here. These are all 4 right angles in here. And it's true for a rectangle as well. So what that means though is that the right angle is exactly 90 degrees. And if you get an angle that's bigger than 90 but less than 180, then we say it's obtuse. And finally, a special angle here is a straight angle. It's a straight angle, it makes a straight line. So those are ways that we classify angles. And so let's just move on. I think that's simple, right? Oh, you want to write those down? All right, I'll give you a moment to write those down if you want. If you want to take Cornell notes, feel free to. I could slow down just a little bit. Keep in mind also that I will be uploading this into YouTube, so if you want to finish your Cornell notes, you can always do that. I mean, you could go on YouTube and watch the video and say, oops, what was that point? I wanted to add that to my Cornell notes. And the nice thing about having it on the video is that you could always hit pause, right? And so you can finish your notes. Okay, let's move on. So, Use the diagram to find the measure of the angle. Then classify. Oh, by the way, when we're trying to find the measure of an angle, you know how like when we were talking about segments, we had AB and we had that mark, right?
Yes.
Well, what did it mean if we had AB without a mark? That's distance, right? Or length, right? Length or distance. Okay, so if you're trying to measure an angle, a segment, we leave the mark off there. In a similar way, we use this little bitty m if we're trying to find the measure of an angle. Like, if we're trying to find the measure of angle ABC, we'll use this little bitty m to talk about the measure of an angle. Okay? Alright, just so you know. Anyhow, let's go back to our picture now. And what we want to do is use a protractor. Now, some of you guys have never used a protractor before, so I'm going to talk about this protractor. It's what we use to measure angles. And protractors are used in construction all the time. Whenever you lay out a plot plan to build a house, you use a big protractor, but nonetheless it's a protractor. But you'll notice there's two sets of numbers. These are scales. And there's one number on the inside going this way, and then there's a set of numbers on the outside going this way. And so the protractor measures the angles. If you have, for example, if your angle starts over here and you're measuring the angle going that way, okay, then you want to use this scale on the inside. Does that make sense? So measuring this angle, for example, we could do that real quick. It's 10, 20, 30, 40, 50. And it looks like to me it's right in the middle. Now you'll notice on the outside are a bunch of tick marks. It kind of works like a ruler. So these go up by 1 each time. So if this is the 50-degree mark here, that's 51, 52, 53, 54, 55. The measure of KHJ, that's this angle right here, we just found out it's 55 degrees. Okay? Now, tell me if you have an idea, why is it not 125 degrees? I mean, that's what it looks like out here. So, if anyone has an idea, why would we not call it 125 instead? Well, that's a good answer. First of all, it's less than a right angle, right? And the second thing is that this scale starts over here. So you'd have to have a ray going this way, and then it starts measuring the angle going this way. You see? You see the difference? So the outside scale starts here, it goes 0, and it goes around this way. Okay? If you're measuring from this side and going this way, you use the inside scale. It's got to start off at 0. Make sense? And this side starts off at 0. Okay, I hope this makes sense about which scale that we ended up using on that one. Okay, well, let's move to the second angle. GHK. GHK. Well, that's this one, right? So that's the one that turns out to be. Can someone get the door? Omar, someone? Wow, what a gentleman. Oh, welcome back. Okay. So, in this case, we would say the measure of this ain't what? No, because I'm doing a lesson now.
Okay, I'll be by here late.
Alright. G H K. This one we'd say is the 125. We use this little symbol up here that means degrees. Okay? We measure angles in degrees. And in case you don't know, that's called a degree. And you'll notice that for a half circle, that's 180 degrees. Is this easy so far?
Yeah.
Now sometimes you can add and subtract. Like, where is GHJ? I'm going to use a different color now. GHJ, that's this angle here, right? Okay. Is that one easy? It's 180, right? So that one's equal to the measure of this angle. Well, let's just put an M right here. The measure of that angle is 180, right? Okay, then GHL. GHL. That's this angle right here. That's this one in yellow. That one looks like to me, it starts here, and you're going around this way, you get up to here to 90. So that one's a 90-degree angle. So the measure of this one is equal to 90 degrees. By the way, since it's 90 degrees, it's a right angle. And so whenever we have a right angle, we put a little box thing because it reminds us that it makes like a square, so to speak. And it's similar to the square. Okay, so by the way, if this is 180 degrees, we need to classify these angles now. What kind of angle is this one? A straight angle. Good. Someone's paying attention. That's good. Good, good, good. So we call that a straight angle. And this angle that's bigger than this was 100, whoops, it wasn't 120, it was 125, wasn't it?
Obtuse.
Yeah, it's obtuse, right? Obtuse. And this one, it's not 125, it was 55, so that makes this one acute. Yay. Are we good? It's hot stuff, right? It's cute. Oh. Okay, let's move on. Okay, so name all the angles at the right here. Okay, so what we want to do, we want to use our three letters, right? So this, we'll talk about this angle first. All right. So since there is confusion, we can't call it angle Q, right? That would be confusing.
Yeah.
So we'll have to use the three letters. And so we could call this one angle PQR. And then we can call this angle over here, this one going this way, we can call it angle R. That's an R, right? R Q S. And then how about this one right here, the bigger angle? SQP, right? Angle SQP. This is too easy, right? I'm boring people now. SQP. Now, if we're clever and we recognize certain symbols in the diagram, we should be able to figure out which one's the right angle.
QQS.
PQS. Well, that's this one, right?
Yeah.
And so that one is equal to 90 degrees. And how do we know that? It has that little box symbol, right? Anytime that little box symbol is in the diagram, we know it's 90 degrees, right? So you guys are all smart already?
Yeah.
Already know these things, right?
Yes.
Yes.
Too easy, right? Okay, so we're going to build up to the angle addition postulate, which is similar to the segment addition postulate, right? But before we do that, we need to know about what the interior is. Okay, so here's a little picture of the interior of the angle. Now, interior, I like to think of it as the inside portion, the part that's on the inside. And so, what do you be thinking we call this part out here? Exterior, right? Now, I want to show you a cool little rule on how we could determine whether something's interior or not. So, it's just a little idea, but we're going to see this multiple times in this course. If you pick any point you want on this ray, let's just say it's that point, and then you pick a point anywhere on this ray, that point. If you were to connect those 2 points like that, then that entire ray or that entire segment would lie on the interior. Does that make sense?
Yeah.
You see? And if you do that for anyone over here, you'd be there, you'd be there, you'd be here, you'd be here, be here, here, everywhere else. And so you get the idea. You pick any point you want and you connect them, you're on the interior. Okay? we will use this idea later on when we get to chapter 3. So if you have this idea, you're like, hey, I understand that. We'll also use this idea at chapter 2. So it's a neat idea on how to determine what the interior is. Well, let's move on, because that idea is pretty easy. And now I can talk about angle addition. This is very similar to the segment addition. Remember what we did the other day? We said if you have A here and C is between A and B, if this were 12 and this is 10, what could we say about the total length?
22.
It's 22, right? You can add those two, right? Well, what this one says is that, hey, if there's a ray in between an angle, a bigger angle, so that it makes two smaller angles, you see? Then you can add the two smaller angles and it equals the big angle. You see? These are the two smaller angles. It's very similar to this one. But this ray has to be in the interior portion. If the ray's out here, then that'll no longer be true. Does that make sense? Okay, so the ray has to be in the interior in here. And then you can add up this angle here plus this angle here, and it's got to be equal to the big angle. So that's what we call angle addition postulate. So if you want, you could write that down in your notes somewhere. It's going to also be on YouTube here in just a little while. So don't worry if you don't quite get it. About an hour or so after my class, it will be in there. So, you ready to move on? We're going to do some simple problems now.
Yes.
And some of the problems will be algebraic ones, I'm sure. Right? 'Cause everyone loves algebra, right?
No, I just had to like it.
Okay. Well, you're going to get some practice here. Okay, so let's look at this information. This says the measure of this angle LKN. LKN is this big angle here, LKN, from here to here. We know that that's 145 degrees. And according to our postulate that we just read, it said this one plus this one has to be equal to the big one. And so that's what you do. You just set up an equation thing. This angle is 2x, okay, plus 10. So that's the first angle, right? That's this little bitty angle right here.
Yep.
Then there's this other angle over here. Well, if we add them, so I'm going to add them, 4x minus 3, it's got to be equal to the big one. And so then we put 145 right here. My friends, the geometry portion of this problem is done. The rest of the problem is just algebra. And so if you're having trouble from this point on, it's not geometry that you're screwing up on, it's your algebra skills kind of weak. Okay? So you might want to get some extra practice doing some algebra. And if any of you fall in that category, please let me know. I could probably help tutor you after school. Okay, anyhow, or there might be some other tutors as well. If we add those x's together, we get 6x. Okay? And if we take these two together, we get 7. Okay, and then we have 45, 145. It's starting to get easy now. Yeah. Now we move the 7, right? Anytime we move across an equal sign, though, we have to do operations. Okay, so we're going to want to move across this equal sign, so what we do is the inverse operation. So to move 7, we have to do the inverse. The inverse of addition, of course, is subtraction. So we subtract 7. So it gives us 6x is equal to 138. And if we divide by 6 here, divide by 6 here, I think we get x is equal to 23. Same number as the number of ingredients in Dr. Pepper, right?
Carlo.
23? Same number as Michael Jordan? How about that? Okay, so only a bozo stops here, though. My students don't stop here because they read what the question was. we're actually asked to find the measure of those two angles. So what we need to do is shove the x back in right there. Bam. Shove it in right there. Bam. So if we put it in there, we find out the measure of angle LKM is equal to what? 2 times 23 is going to be what? 46? And then add 10?
56.
56, right? Now, by the way, can someone tell me a quick way to find this one without putting it in? For x? Yeah, a real quick way to do it? We know the total, right? We've used up 56 of them, right?
145.
So, yeah, if we just subtract 145 degrees, we subtract 56, we can find that angle without substituting in it. I'm not sure which one's faster, but in any event, what do we get? That wasn't so fast after all, because now I need to do math in my head. So let's see, borrow over there, right? So we put a 3, and then this becomes a 9. That becomes 89 degrees, I think. Is that right? So this angle here is 89 degrees. Any preguntas? Did I do that right? 89 and 59 or 56. That should add up to be 145, right? Okay, so there's a typical problem, and the problems usually don't get any harder than that. So if you can handle this one, you should be able to handle all the other ones. So let's try these out now. Now here you have to be a little bit careful here. You have to recognize what type of angle this is. Well, first of all, they tell you a straight angle. And everyone should know that the measure of a straight angle is 180, right? And this one has a right angle symbol in it. So these two must add up to be 90. So naturally what you do is you just set up an equation. This angle plus this angle has to be equal to the big angle, which we're saying is 180 degrees, right? So that gives us an equation again. 10x minus 5 plus this angle, 4x plus 3. That's got to equal 180. Okay? And then from here you just do your basic algebra skills. Now what do we know about this one? Since there's a right angle symbol in there, we know that these two angles have to add up to be 90 degrees. So what we're going to say is that this smaller angle plus this one over here, those two have to add up to be 90. So 2x plus 2 plus x plus 1 equals 90. So sometimes you have to use your observation skills and just look at it a little bit and say, well, what do I know? And sometimes you actually have to read the problem. They tell you it's a straight angle. Over here they tell you have a right angle. And you have to say, well, I know that means 90. I know this means 180. Okay, well, hopefully the algebra skills don't get you hung up. When we add those two together, we get 14x. We add these two together, we get not 8.
2.
Negative 2, there we go. And then it equals 180. We'll move the 2 over. And we get 14x is equal to 182. And just like that, I can slide down further. And divide by 14 here and divide by 14 here. And I think we get x is equal to 1. So 14 goes into 18. I think we get 13. Now only a bozo stops there. My students always say, hey, what was I asked to do in the first place? And so my students always go back and answer the final question. Right? But bozos from other schools, they just don't know what's going on. So we got to put that x in right there. And then we got to put it in right there, right? I'll let you do that on your own. Let's come over here and do this problem now. We can combine those two x's, right? 2x plus 1x gives me 3x. 2 plus 1 gives me a 3. And of course that's equal to 90. Now we'll subtract 3, subtract 3. Is this stuff too hard for anybody?
Yeah.
It is?
Yeah.
87, right? And then what do we want to do? We want to divide this side by 3 and divide this side by 3. We get x is equal to 29. It's hard? Alright, so like I said, only a bozo stops there. We always ask ourselves, what were we asked to do? So what we need to do is take this 29 and substitute in right there. That makes it real easy, doesn't it?
Yeah.
29 plus 1 makes this angle 30, right?
Yeah.
And if you know the total is 90, we can say that one's 60, right?
Yeah.
Because those add up to 90. That's always the faster way, I think. Any questions so far? We're doing pretty good? All right, I think we're almost done. Let's see. Oh, now we have an angle bisector. Just like a segment bisector, remember the symbols we use for a segment bisector? If there's a thing that came through like this, you know, like this, what would we do? We'd say that this side is congruent to this side, right? And we'd have M right here. This is a midpoint.
Yeah.
Well, that's kind of what we did when we had segments, but angle bisector works the same way. If you have an angle like this, you have a bisector that comes right in through the middle. Bam. It cuts the angle right smack in half. And so the angles are going to be equal. And so to show that in the diagram, we used a single tick mark and a single tick mark here. Does that make sense? That's our little congruent symbol. Remember when we're doing segments? If you put a little tick mark on these angles, that means those two angles are congruent. And that means that's an angle bisector. Right here, angle bisector. Pretty easy idea, right? Here's a little, let's use an idea now. Okay, so we know that YW bisects this angle, so it cuts it right in smack in half. Now sometimes in your diagrams they'll use this arc thingy. Let me show you a variation of that. If there's more than one angle that you're talking about, you might use two of them. Okay? And that would mean that these two angles are congruent. If you use a single one, that means those two. Sometimes you'll use three of these. I personally like the way that I was showing you. I like to use the tick mark and put the tick mark right there. Makes it easier for me to see. Anyhow, just be aware of the notation your book uses at times. You want to get that? Okay, so what are we told in this problem? We're told that angle XYW is this one. We're told that that's 18 degrees. Hi, how are you?
Good. I need you to make sure that these are your first period classes, then I need you to sign the date.
So back to the lesson here. We have 18 degrees up here. Well, since this angle is congruent, it means this angle is 18 degrees, right? And what are we after? We're angle XYZ. Well, XYZ is the bigger one. It's XYZ is this one. So naturally, by the angle addition, we can add those two. We can find out that the measure of that angle is equal to, what's that, 36? 36, I think. 36 degrees?
Yeah,
18 plus 18? 36. Anything too hard here?
No.
Even a freshman can get it, right? Alright. Now we kind of wrap up everything there. There's the basic summary of what we've been doing. Now let me go ahead and give you the study guide. We got 20 minutes right now. You can finish the study guide in class. And then what do you want to do? You want to do the book assignment tonight for homework, okay? Oh man. What are you doing there? Study guide, again, you can finish this easily in 20 minutes. So we'll do it right now. Get this done and turned in. It's only about 4 problems and some 4 blanks.
Mister, can I get my homework from that box?
Well, hold on. Can we get this passed out first?
Or we forgot to plug in the apps. This is the date?
Oh, my.
Okay.